Science communicator, recently made headlines when he revealed that Voyager 1 had detected a staggering 300 massive objects in the far reaches of space. This revelation has ignited intense curiosity and raised even more profound questions. What are these mysterious objects, and where did they come from? Join us on an awe-inspiring journey as we delve deeper into the mysteries hinted at by Voyager's astonishing findings, shedding light on the remarkable discoveries that continue to redefine our understanding of the universe. For nearly 5 decades, the Voyager spacecraft have provided us with some of the most extraordinary and breathtaking views of our solar system. These missions, however, were not designed to last this long. Back in the 1970s, scientist Michael Minovich came up with a revolutionary idea. Spacecraft could use the gravitational pull and velocity of planets to slingshot themselves further into the solar system, accelerating their journey in ways previously unimagined. Initially, the Voyager missions were only meant to last 5 years, but their lifespans have far exceeded that expectation, thanks to innovative planning and a bit of luck. Launched just weeks apart in the summer of 1977, Voyager 1 and Voyager 2 set out on a remarkable journey to explore the distant giants of our solar system, Jupiter and Saturn. The two spacecraft provided us with some of the most detailed and groundbreaking images and data ever collected, revealing new insights into the atmospheres, rings, and moons of these massive gas giants. But their story doesn't end there. Voyager 2 continued its historic mission, conducting the first-ever close-up observations of Uranus in 1986 and Neptune in 1989, becoming the only spacecraft to visit these distant worlds. This historic grand tour of the outer solar system captured the imagination of scientists and the public alike. Despite completing their primary missions, the Voyager spacecraft didn't simply stop there. Instead, they set their sights on the uncharted, deep reaches of space, far beyond the planets we once thought we knew so well. Over 45 years later, both Voyager 1 and Voyager 2 are still traveling through the cosmos, continually sending back vital scientific data from the farthest regions of the solar system and beyond. In 2013, NASA made a groundbreaking announcement. Voyager 1 had officially entered interstellar space, the region of space beyond the influence of the Sun's magnetic field and solar wind. This was akin to leaving the bustling solar system and venturing into an uncharted, serene wilderness of stars and cosmic dust. Not long after, in 2018, Voyager 2 followed in Voyager 1's footsteps, crossing into interstellar space as well, nearly 17.7 billion kilometers from the Sun. These two spacecraft are now the only objects ever created by humanity to venture this far, giving us invaluable insights into the conditions of the space between the stars. The data sent back from these legendary spacecraft has illuminated the nature of the interstellar medium, the matter and radiation that exists in the vast expanse between stars. These missions have given us a much clearer understanding of how the solar wind interacts with the interstellar medium. One of the most fascinating discoveries made by the Voyagers is the detection of cosmic rays, mysterious, high-energy particles that are far more intense in interstellar space than within the protective boundary of the heliosphere, the Sun's bubble-like shield that surrounds our solar system. The difference between the two environments is staggering, like comparing the peaceful calm of a backyard to the chaotic energy of a bustling street. But that's not all. In 2023, Voyager 1 made another unexpected discovery when it detected a faint, low-frequency humming sound. This sound corresponded to the vibration of small amounts of gas particles drifting through the vastness of interstellar space. This revelation has provided scientists with more. Nicola Fox, head of NASA's Heliophysics Division, emphasized just how important these discoveries are. For over 4 decades, the Voyager missions have provided humanity with unprecedented knowledge of the cosmos, helping us transform our understanding of the Sun's influence on our solar system in ways no other spacecraft has done before. One of the most extraordinary aspects of the Voyager missions is how the spacecraft have managed to continue functioning despite the many challenges posed by the extreme conditions of space. Both spacecraft rely on a plutonium-based power system, which decays over time and generates less heat as the years go on. To cope with this, NASA has had to make difficult decisions, shutting down non-essential systems and even cutting power to the heaters that keep the spacecraft's instruments warm in the freezing void of space. Despite this, all 5 of Voyager's key instruments have remained operational since 2019, far beyond what anyone expected. Even more astonishing is the fact that these spacecraft, which were built in the 1970s and have only 70 kilobytes of memory, less than most modern digital watches, are still transmitting vital data. This has left scientists scratching their heads, wondering how these ancient spacecraft are still managing to operate under such extreme conditions. It's truly a testament to the resilience of these machines and the brilliance of the engineers who designed them. As Voyager 1 and Voyager 2 continue their journeys through interstellar space, they've also provided us with insights into the shifting boundaries of our solar system. The heliopause, the outermost edge of the solar wind's influence, is not a static boundary. In fact, over the past decade, scientists have noticed that the position of the heliopause seems to shift over time, with measurements from both Voyager's and NASA's Interstellar Boundary Explorer, IBX, providing crucial data about these movements. One particularly intriguing discovery came in 2014, when IBX detected an unusual brightening of energetic particles. This anomaly didn't fit into current models of the heliosphere, raising new questions about its structure and behavior. These unexpected findings challenge long-held assumptions, suggesting that the heliopause may not be as simple or as stable as previously believed. The Voyager's observations of these changes have sparked a re-evaluation of how scientists understand the boundaries of our solar system. In May 2023, Voyager 1 faced an unexpected issue. Its Altitude Articulation and Control System, AC, which manages the spacecraft's antenna, began to send back puzzling data. For a time, it seemed as if Voyager 1 was struggling to communicate, almost as though it were experiencing some form of electronic seizure. However, despite these strange reports, Voyager 1's radio signal remained strong and stable, indicating that the spacecraft was still functioning properly. NASA soon discovered that the problem stemmed from an inactive computer that had been used for some time. The solution was straightforward: they simply switched to a functioning computer. But the exact cause of the issue remains a mystery, and NASA continues to investigate the anomaly in an effort to prevent similar problems in the future. After nearly 5 decades, the Voyager spacecraft remain humanity's most distant emissaries, sending back vital data from the farthest reaches of our solar system and beyond. Despite their outdated technology, including analog cameras and computers with less memory than a modern-day smartphone, these spacecraft have left an indelible mark on our understanding of the cosmos. They've provided unprecedented insights into the planets and moons they've explored, revealing active volcanoes on Jupiter's moon Io, the complex ring systems of Saturn, and the potential for alien life in the subsurface oceans of Europa and Enceladus. One of the most poetic moments of the Voyager mission came in the early 1990s, when Voyager 1 took one final look back at our solar system, capturing the iconic pale blue dot image. Taken from a distance of over 6 billion kilometers, the image showed Earth as a tiny, fragile speck in the vastness of space, an image that continues to humble and